Okay, welcome to lesson 3 of two-variable statistics, and what we're going to be focusing on today is using the Ti-Nspire to find the line of best fit, and we're going to be making some interpretations of those lines. So if you just recall from the previous lesson, we were trying to fit a line to data, and what we were doing when we tried to fit that line to data was to try and get a line that passed through kind of the middle of most of the points and also passed through the average X score and Y score. And of course, in the case of the example that I have on the screen now, we have our an outlier value over here, and so that tends to pull our regression line towards itself and maybe gives us a slightly less accurate one. Okay, but what we're going to do today is focus on doing that by the Ti-Nspire, and so this time what we're going to be doing is getting a very accurate answer as opposed to just an estimate using algebra like we did last lesson. Okay, so what we're going to do is I'm going to sorry, let me just mention this, the idea of interpolation and extrapolation and axial intercepts we'll discuss in the context of the examples as we go. Okay, so what we're doing is we're using the same data as we used in the very first lesson, so we can save a little bit of time on data entry. And so we want to access the document that has all of these lists. This was our list of round 1 and round 2 golf scores. And so I'm going to go over to my TI, I'm going to go to my documents, and I have mine saved as two variable stats lesson 1. And so I'm going to open that up. And here you can see I've got the lists of all of my data, round 1, round 2, turnover fouls, etc. Okay, and if I go over here, this is where we drew our scatter plot. This is showing the scatter plot for body temperature and air temperature. And so what we're going to do now is go back to the examples, and what we've been asked to do is to find the line of best fit using the regression function on the Ti-Nspire, and that is going to be for our golfers. Okay, so I could use this page. What I'm going to do is just go ahead and create a new page, and the page that we want to create is a data and statistics page. The first step in regression on the TI is to get a scatter plot, and so I'm going to click down here. What I want is the round 1 scores as my independent variable. So we're saying that the round 1 scores cause the round 2 scores, or potentially influence them. And then what I'm going to do is come up here and click my second variable, which is going to be the round 2 scores. And here we can see we have our scatter plot of our scores. The actual process of finding a line of best fit on the calculator, very, very, very simple. What you need to do is go into the menu under the Analyze options. Number 6 is Regression. Let me just undo that, sorry. Analyze, and under the Regression, we have all sorts of different options for exponential, power, quartic, cubic, etc. What we want is essentially one of the first two. It doesn't really matter which one you pick. I'm going to show the linear mx plus b, and what it does is immediately produce for me the line of best fit, which has an equation y equals 0.41, if we're rounding to 2 decimal places, 0.41x plus 50.01 if we are rounding to 2 decimal places. So I'm just going to come over here and make a note. So it's technically y equals 0.41x plus 50.01, rounded correctly to 2 decimal places. Do keep in mind that really what we're talking about is in the place of y, you can see the label up here. This is the round 2 score, which is going to be dependent on x, which represents our round 1 score. And so you could write this in the context of the problem, which would be to say round 2 score is equal to 0.41 times the round 1 score plus 50.01. Okay, so that is our linear model, and one of the things we use linear models for or any mathematical model, in fact, is to make predictions. And so if the prediction is within the domain and range of the data, then we call that interpolation, I-N-T-E-R, and if it's outside of the domain and range of the function, then we call that extrapolation. And all that happens is if we are extrapolating, we need to be a little bit cautious. We have to be a little less confident in the predictive value of the model because the data that produced the model is from a different domain and range. Okay, mechanically, how is it that I do this? Essentially, what I'm trying to do is find the y value when the x value is 69, and so this is a substitution. How do I know that it's the x value which is 69? Because we are told they shoot 69 on the first round, and so I sub it in the place of x, or the first round variable, and I'm now going to predict what a golfer would score if they shot 69 in the first round using our mathematical model. And so I'm just going to use a calculator page in this case. There is another way you can do it on the graph, which I'll explain in the next example. Okay, and so what I'm going to do is I'm just going to add a calculator page, and I'm going to do 0.41 multiplied by 69, and then I'm going to add 50.01, and what I have is a score of 78.3, and so we are giving an estimate of the score, 78.3, based on our mathematical model. Is the prediction reliable? Like I mentioned above, since the x values are the smallest x value we have here, if we scan this list, is 79, a score of 69 is well outside the domain, and so we won't be very confident that this is going to be an accurate prediction. Let me just show you very quickly. If we go back to our graph, what you can do here is you can, under the Analyze menu, you can choose to trace the graph, and when you trace the graph, if you move to the left with the cursors, it will adjust your window for you as you go, and we can just scroll along until we get very close to the value of 69. We can't get exactly to the value of 69 because it's the trace function, but we can get fairly close, and you'll see that it gives the values over here. Sorry, let me just scroll back. It's going to give the values of 78.2 and 78.4 because I'm jumping just above and just below 69. Okay, so a slightly less accurate way of doing it. Okay, so let's jump to the second example now. So very similar, we're going to do a scatter plot for the age of the car and its value and find a line of best fit. And so we're going to go in, once again, I'm going to well, actually this time what I'll do is I'll use the, actually I'm going to add a page again. So either way, you can go and modify the previous graph, but I'm going to add a page in so we have those saved for later. So what I want is a data and stats. This time what I'm looking for is car age. I'm interested in the age of the car, and I'm going to map that with the value of the car. So here I have my spreadsheet, and then what I'm going to do is I'm going to find the linear regression. I'm going to show you another way that you can do this using the stat menu. And so I've got those two things graphed. If we were to do that using the graph, what we can do is come down to the Analyze, Regression, Show Linear. There's our equation over there. And the only downside of this is that the calculator doesn't treat this as a function that I can then graph on, so I can't plot different values. So I'm going to just show you, if I add a page and I use a calculator page, it is possible under the Statistics menu, Stat Calculations, Linear Regression, to do this slightly differently. If I have car age as my one list, value is my second list, and what it's going to do is it's going to save the regression equation to F1. And so the advantage of this is it does the calculation for me, gives me the same equation, minus 1593x, because you'll see here it's mx, so that's the slope, and the b value is 15,203. if I were to go back here, you can see that's the exact same equation. And so if I jump forward again, the advantage of doing it this way is, of course, that if I then go and add a page over here, and what I'm going to do is I'm going to add a graphing page, and I scroll up, you'll see that F1, the equation from the linear regression, has been saved. I can check the box over there if it'll let me. Hopefully it'll let me. Doesn't want to let me click on that box for some reason. Let's see if I tab. There we go. And then I'm going to hit enter, and what it's going to do is it's going to graph that function for me, and then I can use this with the trace function to substitute in different values. Okay, in the interest of time, what I'm going to do is just jump back to my original graph over here, and what we've been asked to do in the second part. So first let me make a note of my equation. This time what we have is value, because that is the independent variable, is going to be equal to minus 1593.89, because we're going to do this correct to 2 decimal places, multiplied by years or car age, and in this case plus 15,203.71. Okay, and then we're going to go on and do the second part over here, which is we are asked once again to do a prediction for the value of the car. So we're going to predict the value of the car in 10 years time, and so I'm going to go ahead and make a substitution as I did in the question above. Value is going to equal minus 1593.89 multiplied by 10, because it's of course 10 years, plus 15,203.71, and I'm going to do that on the calculator over here. I'll go back to my calculate page, and I'll just do that calculation in here, and so we have negative 1593.89 times by 10 plus 15,203.71. I'm going to hit enter, and herein you will see the small challenge that we face. So there I have my answer, minus 735.19. And what you can see from this, what does this tell you about your model? Hopefully what you realize is that it's not possible to get a negative value on a graph, or rather the value of the car should not be able to fall below 0. And so that indicates one of two things. The first thing it could indicate is, of course, that a linear model is not the best fit. The second thing that it might indicate is that the model only applies for a particular domain and range. So later on, when we do correlation coefficients, we'll have another basis to make the decision about whether this is the ideal model or not. But for now, what you can see is that we have got a problem with our model because it is producing a negative car value, which of course is not possible. Okay, what I'd like you to do at this point is to turn your attention to example 3 and give this an attempt. So you can go ahead and do this on your calculator in much the same way as I've done before. See if you can get some answers to parts A, B, and C. And in part 2 of the video, I'll go over the answers to there and we'll see how you've done.